Now finally, let's move on to the third type of integral problems in section 7.2. Those types of problems require this box number 2, the mechanism to change products of sinusoid into sum. We have three formulae here. Sine of A times cosine of B equals 1/2 of sine of A minus B plus sine of A plus B, and so on. So sine times cosine becomes sine of difference plus sine of sum. Sine times sine becomes cosine of difference minus cosine of sum, etc. This is very confusing. You can actually easily deduce this from the sum and difference identity from the right-hand side, but doing everything after deducing from the standard identity takes too much time, and always there are some dangers regarding signs. As you can see, negative signs are flying around. There's a subtle difference between sine and cosine, so it's quite confusing. So what I would rather encourage you to do is write down somewhere and then bring it back whenever it becomes necessary. For example, if you're taking an exam, prepare this formula and a bunch of others too in this one-page formula sheet, and then make sure you know how to bring it back as quickly as possible whenever you meet these kind of problems. And how do we handle this kind of problem? Well, let's do that using my Mathematica notebook. Here, okay, I summarized this one again in this lecture note, and here's some more problems. How do we handle integral of, say, for example, second problem, cosine of 2x times cosine of half of x? Well, this is product of two cosine functions, so the third formula will apply. So you can rewrite this product into 1/2 times cosine of difference, so 2x minus 1/2 of x, so we have 2x minus 1/2 of x, generating 3/2 of x, plus cosine of sum, so 2x plus 1/2 of x, so we have 5x over 2. After that, routine antiderivative computation. Antiderivative of cosine is sine, so we have sine functions, and because of the chain rule, we have this 1/3, 2/3, and this 2/5. What if we have some problem like this one? Again, no sweat. We just have to apply one of these three formulae, and it's going to be the first one, sine times cosine. So 1/2 sine of A minus B, so 3x minus x. So here it is. 1/2 of, it's a little bit difficult to see, so let me do a little bit of editing here. Okay, does it look better, or did I make it worse? Let's see, 1/2 times sine of difference, so 3x minus x, so we have x, plus sine of sum, so 3x plus x, so we have 4x. After that, let's just recognize that antiderivative of sine is negative cosine, so we have negative cosine and another negative cosine. We have to apply the chain rule backwards, so extra 2 is divided and extra 4 is divided, so we have negative 1/4 and negative 1/8 respectively. And that's about it. By the way, these kind of problems are especially the sine cosine times type of problems appear very often in physics whenever you deal with wave motion or optics, electromagnetic waves, all kind of things, so they are important. And also they appear in something called Fourier analysis, so there is a reason we are particularly emphasizing sinusoids, sine and cosines, two different angles or two same angles with two different powers, both of them, compared with those tangent secant problems, or much less cotangent cosecant problems are not that important. Some other problems, okay, here is an exceptional problem. Exceptional not because they are difficult, but because they do not really follow standard strategy. We dealt with the previous 3 types of problems using standard strategies, but a lot of problems are just case by case, and I simply selected 2 easier problems for those exceptions, and here they go. We have cosine of x plus sine of x over sine of 2x here, and my first reaction will be applying some trig identity to make it simple. How do you apply trig identity to the numerator, cosine of x plus sine of x? Not much, because they're simple as possible already. So let's take an eye upon the denominator. Denominator is sine of 2x. So if you apply the double angle formula for sine, then you're going to get something. What's something? Here it is. Sine of 2x is 2 cosine of x times sine of x, as we have over here, and consequently we have simplification. Cosines cancel out, sines cancel out, so we have 1 over sine of x and 1 over cosine of x respectively. Consequently, we have antiderivative of cosecant and secant functions. And all you have to do is just look up the antiderivative table for cosecant function. We have it here. And then secant function there, and that's about it. How about the next problem? This one is a little bit more challenging because it's not obvious which trig identity to use, because numerator is just 1, too simple. Denominator is 1 minus sine of x. Looks like this one is just as simple as it can get too. No square, no double angle, nothing. But still, compared with the numerator, the denominator is a little bit more complicated, so we may have to work something out for the denominator. How do we do that? Well, my reaction for this kind of problem is to multiply the conjugate, 1 plus sine of x to both numerator and denominator. If I multiply 1 plus sine of x to denominator, I'm going to get 1 minus sine of x times 1 plus sine of x, as we see over here. Here, 1 minus sine of x times 1 plus sine of x. And what is that? It is a minus b times a plus b. A squared minus b squared. We're going to have 1 minus sine squared. And that's going to be cosine squared. That was rather ingenious, but once that conjugate part is done, simplification from that point on is not outrageous from that point on. 1 over cosine squared, that's secant squared. Sine of x over cosine squared, we can take substitution y as cosine of x and then dy is sine of x dx. But there's even simpler way. Sine over cosine is tangent and 1 over cosine is secant, so we have nothing more than tangent times secant. Consequently, we have just secant function in the end. Well, what can I say? These kind of problems require experience. So if you meet a lot of integral problems here in the notebook, in the textbook, and also WebAssign homework problems, please do not waste your time complaining, oh, there are too many problems. Just do those so that you solidify your experience, and by the time you meet some exceptional problem, you'll have better intuition how to handle those.